So in this problem, we don't need toucans and blue and yellow macaws, our tropical birds. Don't care. We know we have two birds sitting here. The length of an average toucan is about 2/3 of the length of an average blue and yellow macaw. So I want to define a couple variables here. How long is the average toucan? Okay, it tells me the average length of a toucan is about 24 inches long. Okay? How long is the average blue and yellow macaw? 2/3 of the length of that? Right. It says the length of an average toucan is 2/3 of the length of an average blue and yellow macaw. Well, how long is the average blue and yellow macaw? We don't know. And when we don't know something, that's our variable. So we want to pick a letter to represent the length of the average blue and yellow macaw. What would be a good letter to pick, maybe? M? B? Any other letters? X? Does it matter? No. So usually I recommend picking a letter that makes sense. Why did you pick M, whoever picked M? For macaw. Why did you pick B, whoever picked B? For blue. Okay, they're picking those letters for a specific reason. It says blue and yellow macaw. Blue for blue and yellow macaw. M for macaw. I like M. I like X. Doesn't matter. Just make sure it makes sense. M equals length of macaw. Macaw. Could you pick some other letters? Sure. But I think M makes the most sense here for macaw. Okay, so now we take the information that's in the problem and we write an equation. It says the length of an average toucan is about 2/3 of the length of an average blue and yellow macaw. Well, how long is the average blue and yellow macaw now? No. How long is it? How long is the average blue and yellow macaw? Recently we said we don't know until we did this. So the length of the average blue and yellow macaw is M. The length of an average toucan is about what compared to M? 2/3 of the length of an average blue and yellow macaw. So I'm going to write 2/3 of M is what? The length of an average toucan? So 24? That's the equation. You have to read the sentence. The length of an average toucan is, the word is a key word for an equal sign. So the length of an average toucan is 24 inches long. It says the length of an average toucan is, so 24 is about 2/3 of the length of an average blue and yellow macaw. We don't know that one, so we called it M. That's where the equation came from. And how do I solve this equation? Yeah, multiply both sides times what? What's that called? The reciprocal of 2/3 is 3/2. That allows us to get this problem solved in one move, which is always nice. 2/3 times 3/2 is 1. So I get 1M, or just M, equals 24 times 3/2. You have a choice. You can do 24 times 3 and then divide it by 2, or you can do 24 divided by 2 first and then times 3. I prefer to do 24 divided by 2 first because that gives me a number I can work with easily. 24 divided by 2 is 12, and then times 3 is 36 what? Inches. So don't forget your units on that, otherwise I might think you mean dollars, and then I don't know if you know what you're doing. Section 2 takes what we learned in Section 1 and adds one step to it. And you're going to find in algebra that's basically what happens. You learn something, and then the next section just adds one more thing to it. And then the next section after that adds one more thing to it. So if you don't know the first section, you're going to be having a tough time with the second section probably, and so on down the line. So make sure you learn each section as we go. Section 2 is solving two-step equations. Section 1 was solving one-step equations. So now we have two things we're going to have to do on each of these problems, most of the time. In order to do that, you need this. Determine what needs to be undone first. That is the most important thing about this section, and really everything that we do from here on out in algebra. You got to figure out what has to be undone first. So for example, you get up in the morning, you get ready for school. As you're leaving the house, you put your shoes on, and then you tie your shoes, and then you put your jacket on because now it's cold out, right? And then you walk outside. Is that a reasonable order to do what you're supposed to do before you go to school? Yeah. Well, what if instead I went outside, and then I tied my shoes, and then I put my shoes on? How would that go over? They'd be cold, and if it's today when it's kind of rainy outside, you'd have wet socks all day, right? And nobody wants to walk around school with wet socks. So do things in the right order. It's the same thing with solving equations. You do things in the right order, and you get the right answer. If you don't get the right answer. And then headaches and tears and everything else starts to follow, right? Yeah? Okay. To solve two-step equations, identify what needs to be undone to get the variable term by itself. By variable term, I mean the term that has the variable in it. Get that thing by itself first. And then you can isolate the variable. Usually what that means is, for number 2, isolate the variable, usually means save division for last. When you divide both sides by a number to get x completely by itself, that has to happen last. So for example, 2x plus 3 equals 15. Notice that I have a 2 attached to that x. What am I doing to x right now? What does that say in between the 2 and the x? Multiply. So how do you undo multiply? You divide. Am I going to do that right now? No, I'm not. Okay? That's what I mean by save division for last. Save that division by 2 until the end, and then you'll have just x at the end. For this first part, it says identify what needs to be undone to get the variable term by itself first. The variable term is that guy, the 2x. Get that by itself. What am I doing to 2x right now? I'm adding 3. So how do I undo add 3? Subtract 3. You're going to do this first. What am I left with on the left-hand side? 2x. 3 plus negative 3 is 0. It's gone. That's the whole point. Equals 15 minus 3 is 12. Now, what do I need to do to get x by itself? Now I can divide by that 2. And I get x on the left equals 6 on the right. You can check our answer real fast. Take the 6 and just in your head, plug it in right here. We have 2 times 6, which is 12, plus 3 is 15 equals 15, right? Okay, so we got the answer right. Save the division to last. Basically undo the variable last, because in this one we don't have division. What should we do first on the second one? Yep, we want to undo what's being done to the variable term. That's the variable term. You undo minus 3 by adding 3 to both sides. What do we get on the left? 8 equals t over 2. And then the minus 3 and the plus 3 add to 0. They're gone. So now the variable term is by itself. Notice up here I said isolate the variable, save division for last. We don't have division that we're going to do here. What are we going to do to get the variable by itself? This time we're going to, you could multiply by the reciprocal, which in this case is 2. So you're going to multiply both sides times 2. On the left, 2 times 8. 16 equals t. Circle it. And what should we do now? Yeah, check it. It's really easy to check. Just get in the habit. 16 goes in right here. 16 divided by 2 is 8 minus 3 is 5 equals 5, so we got it right. Third one, what should we do first? Right, we want to undo what's being done to the variable term. What's being done to the variable term right now is we're adding 11. So to undo that, we subtract 11 from both sides, thank you. And what's left on the left? 2x. The 11 minus 11 is gone, the equal sign comes down, 40. And now we will divide both sides by 2. X equals 20. And now we will plug it back in and check. 2 times 20 is 40 plus 11 is, and that's the right answer. So that's how you do it, okay? Save the undoing of the variable term until the end. Get rid of what's being done to the whole variable term first, and then move from there. It's like digging a hole. Just kind of start digging down until finally you unearth what you're looking for. All right, so now we have a couple of story problems here. They're not that big a deal. You just got to read the problem and remember that you're trying to write an equation. So it says, you are making a bulletin board to advertise community service opportunities in your town. Is there any useful information in that sentence? No, but it sort of sets up what we're doing, okay? Can you picture a bulletin board where you might put some signs on it or something? All right, so that's what's going on. You plan to use half a sheet of construction paper for each ad. What does half mean? 1 over 2, yeah. You need 5 sheets of construction paper for a title banner. Can you picture what a title banner means? Yeah, like across the top, it's apparently going to take 5 sheets of paper to do that. Then it says you have 18 sheets of construction paper. How many ads can you make? Well, what do? A few minutes ago I told you the first thing that you need to do in any story problem is what? Define your variable. If you didn't write that down, you need to write that down because that is the most important thing with story problems. So what are we going to call our variable here? What is the thing that we can change or that we don't know? Yeah, right here it says how many ads can you make? I don't know. That's what we got to figure out, right? So that's my variable. A for ads. Good. So I'm going to write A equals not just ads. It says how many ads. So A will be the number of ads. That is not hashtag of ads. You guys know what that symbol stands for, right? Thank you. All right, so from that, now that we know what variable we have, now that we know what we're looking for, we can start to write an equation. So in order for you to do this, they gave us some information that we're going to use here. How much paper are we going to use? We're going to use all 18 sheets because we want to make as many ads as possible, right? So however many ads it is that we make, we're going to have 18 sheets of paper used. Now, from the information up here, what do we know? Right, good. You need 5 sheets of construction paper for a title banner. Automatically, you have to have that, okay? So however many sheets over here I use, 5 of those sheets are going to go towards that title banner. So I'm going to write 5 plus, because I'm going to use more than that. The other piece of information here that's pretty important is the half. You plan to use half a sheet of construction paper for each ad. If you remember back in chapter 1, I told you that for each, or per, or for every, always gave something away. What did it give away? No. No. Like per day, per dollar, per person, for every person, each day, each hour. What is that giving away? Nope. Look at what it says after for each. For each add? What is that? It's not an operation, I'll tell you that. It's not an exponent either. Not a grouping symbol. What are adds in this problem? Huh? Right, half piece of paper per add, right. But what is an add? It's the variable, yeah. For each what? For each add. Well, look, add is my number, or my variable. The number of adds is my variable. The words for each, or per, or for every, or things like that, usually give away the variable. So it says you plan to use half a sheet of construction paper for each add. That means that the half is going to be attached to my add in some way, attached to my A. So how can I write that? There you go. Okay? Look for the verbal clues that they give you. The clues that they write will help you assemble this problem. Think about it. If I use half a sheet of paper per add and I used one total piece of paper, how many adds can I make from one piece of paper? 2. How many adds can I make from 2 pieces of paper? 4, right? Okay, so that's where this is coming from. All right, so now we have our equation written. What do I do? Just do it. Solve for A, so we're going to subtract 5 from both sides to get the variable term by itself. Well, what do I get? 1/2 A equals 13. Right, to get A by itself, multiply by the reciprocal, which in this case is 2. So now I get A on the left equals 26 on the right. 26 what? 26 adds. Remember that we defined a variable as the number of adds. So it's 26 adds. That's your answer. Again, make sure that with the story problem you come up with an answer that makes sense for the problem. Don't just leave it as 26. All right, question. Suppose you now use 1/4 of a sheet of paper for each. There's a typo here. This should be add. And 4 full sheets for the title banner. So instead of how many sheets before?
5.
Instead of 5, now it's 4. And instead of how many adds could you make now? So now you're going to have to define a variable, write a new equation based on what we did before, and then solve it. Go ahead. So with the differences in this problem, what will my equation change to? 4 sheets of paper plus 1/4 sheet of paper per add, and I want to use all 18 pieces of paper. So to solve this one, we will subtract 4 from both sides, and we get, okay, and to solve for A, okay, this is a good point. You could divide by 1/4, but to divide by 1/4 by 1/4, you'd have to do leave it, change it, flip it, right? Which would give you 1/4 times 4. So save yourself that, and just go with times 4 at both sides. And you get A on the left equals, good, 14 times 4 is 56. If you don't know 14 times 4, real quick off to the side, there you go. Faster than typing into a calculator, believe it or not. 56 adds. Don't forget to put a label on there and then circle it. And that's your answer. So those first few problems that we did were like the general problems that you're going to see most of the time. These 3 examples here are problems that you might see sometimes. And there are problems in the homework section that ask you to do things like this. You just need to remember that you want to sort of dig out x, or whatever variable it is. So you need to find the thing that's being done to x last, and undo that first. So like you put your shoes on, you tie your shoes, you put your coat on, you would step outside. What is the first thing that I would undo if I was undoing what I just did? I go back inside, right? And then I would untie my shoes, and then I would take off the shoes. So you need to sort of figure out what's being done last, okay? So in this problem right here, I have x minus 7, and then everything is divided by 3. What is the thing that's being done to x last? Yeah, you divide by 3, okay? Think of order of operations. This has to happen first because of that grouping symbol, and then you take care of the division, all right? So we are going to undo that division in this case first, even though on the previous page I said don't divide first. In this case, we are going to divide first because that's the last thing that's being done to x. So in order to get rid of the division, I'm going to have to multiply both sides times 3. Now, what this says right here is 3 times something divided by 3. It looks weird. It's not like your usual 3 times 2 divided by 3. But it is 3 times something divided by 3. What's 3 times something divided by 3? What? The something, yeah. 3 times Caleb divided by 3 would be? Right. You're just going to get what you had in the first place, okay? We did something and then we undid it. So I get this thing right here, x minus 7, equals, on the right side, negative 36. And now we're right back into section 1. We got one thing left to do, which is, good. We got to undo the subtract 7 by adding 7 to both sides. And we get x on the left equals, nice, negative 29 on the right. And then what should we do? Check it. Take your negative 29 and plug it in. Negative 29 up here, minus 7 would be negative. I got a negative minus a number. That means I'm going to take the two numbers and add them and then keep the sign. So negative 29 minus 7 is negative 36. Negative 36 divided by 3 is negative 12. That's what we had. So that's our answer. Okay, it does work. That's the answer. So on this one, 6 equals x minus 2 divided by 4. What is the first thing I need to do? Why am I multiplying by 4? That's the last thing we did was divide by 4. So we're going to multiply by 4 to undo that. And what do I get on the left? 4 times 6 is 24. What do I get on the right? The x minus 2. The 4 divided by 4 there, that's a fancy 1. That turns into 1, and I'm left with just the x minus 2. And one less thing to do. Add 2 to both sides to get x by itself. 24 plus 2, 26 equals x. Negative 2 plus 2 is 0. It's gone. 26 equals x is my answer. What should I do now? Check it. 26 minus 2, 24 divided by 4 is 6. So 26 equals x is my answer. All right, go ahead and do the last one. Remember to show your work. Means write down the problem. Of course, you don't have to on your note packet. It's already there for you. But on your homework, write down the problem and then show all your steps. What is our first step here? Multiply both sides times 6. Okay, on the left, what do we get? No. We get x plus 5. The 6 divided by 6, our fancy one, they're gone. Equals 90. 15 times 6 is 90. Now what? Subtract 5 from both sides. So I get x on the left equals 85 on the right. What should we do? Check it. 85 plus 5 is 90 divided by 6. Hopefully it's still 15. So that is the correct answer. 3 more problems and we're done with the section. Using deductive reasoning. Deductive reasoning is kind of like being a detective. They follow step by step by step from start to end to come up with an answer. If you see the directions justify each step, watch for those directions. if you see those directions, it means that you need to set up two columns like we're about to do here and show each step for the math in the left column and then list the properties that you used to allow you to do that in the right column. For example, what is the solution of negative t plus 8 equals 3? Justify each step. This is how you do these problems. Step 1 is you write down what they gave you. Negative t plus 8 equals 3. And then over here you're going to write down what allowed you to do that. Where did I get that from? It was given to me in the problem. So that means our first step is going to be given. You guys are going to be doing a lot of these in geometry. And this is the procedure you'll follow. Okay, so now we want to move on to the next thing. What do I need to do to start getting t by itself here? Yeah, we want to get t by itself, so we're going to undo that adding 8 by subtracting 8 to both sides. Minus 8, minus 8. I can draw my line, and now step 2 will be the answer to what I wind up with here, which will be negative t. 8 minus 8 is 0, it's gone. Equal sign comes down. 3 minus 8 is what? Negative 5. Negative 5. All right, what property allowed me to do that subtraction on both sides? I'll give you a hint. The subtraction, yeah. Subtraction, property of equality. How do I know it's a subtraction property of equality? Because I subtracted. Okay, so that's the property you used. Now, what is the next thing that we need to do? We want t. We have negative t. No good. What can we do? What? I want just t. I want 1 t. I got negative 1 t right now. If I add 1 to both sides, I'll wind up with negative t plus 1. That's not what I want. If I subtract 1, I'll wind up with negative t minus 1. That's not what I want. There you go. Or, so he said you could divide by negative 1, because negative 1 divided by negative 1 is positive 1. Or we could, instead of dividing, we could multiply by negative 1. Okay? It's up to you. For me personally, I prefer multiplying. So now I'm going to multiply both sides by negative 1. Include all your parentheses. Step 3, what will I wind up with on the left-hand side? Positive on the left? T. Negative 1 times negative t is positive 1t, or just t. Equals what on the right-hand side? Positive 5. And what allowed me to do that? What did I do? I multiplied, so I'm going to have the multiplication property of equality. Okay, am I at my answer? Yeah, I have just t equals some stuff. T equals 5 is my answer, so I'm done. That is how you do a proof. This is called an algebraic proof. So we have 2 more problems to practice. Let's talk our way through the first one. What is the solution of x over 3 minus 5 equals 4? And then it says justify each step, which tells me I'm going to do what? We're going to do a proof. We need to draw that table. On the left side goes steps. And on the right side goes reasons. Okay, what is my first step going to be? Write down what they gave you. So step 1, x over 3 minus 5 equals 4. And what is my reason there? It's given. So step 1, given. All right. Now we're just basically solving the equation, but we just have to write down every step along the way. So what am I going to do first? Good. We need to get the variable term by itself, so we're going to add 5 to both sides. draw my line here, and now my answer is going to be step 2. What do I write? X over 3 equals 4 plus 5 is 9. So that is my step 2. And what allowed me to do that? Addition. So I write addition, property, good, of equality. Okay, looks like we got one more thing we got to do here. Good, multiply both sides times 3 to get the x by itself. So for step 3, I will write x equals 27. And the reason that allowed me to do that, good. We multiplied, so that's the multiplication property of equality. And we have our answer, so we're done. Go ahead and do the last one. Same way. What should I write for the third one? I need the table, steps, reasons. Okay, step 1. The equation is 10 plus 2x equals 20, and the reason is given. Okay, step 2. Good, to get there we're going to subtract 10 from both sides, and my answer will be equals 10, and what allowed me to do that? Subtraction property of equality. That's acceptable abbreviations there. Okay, next thing. Divide both sides by 2, and I get step 3, which is x equals 5, and the thing that allowed me to do that is division, div prop of equality. Done. No big deal. That's the whole section.